Okay, so this is problem 26. I'm going to read it. Exit sign problem. The base of a 20-foot tall exit sign is 30 feet above the driver's eye level. So this represents the exit sign and it starts 30 feet above the driver's eye level. This is where the driver is. When cars are far away, the sign is hard to read because of the distance. When they are very close, the sign is hard to read because the drivers have to look up at a steep angle. The sign is easiest to read when the distance x is such that the angle at the driver's eye is as large as possible. The angle that the sign makes from top to bottom. Part A, write theta as a difference of two inverse cotangents. Okay, so here the two angles that we're going to take is the angle that includes the large right triangle. Okay, and we're going to subtract the angle of the blue smaller triangle. Okay, so the large triangle, its cotangent is x adjacent over opposite, and the opposite is 50. So theta will be the difference of two triangles, two angles. The first one is the arccotangent of adjacent x over opposite, and in this case opposite is 50 feet, minus this angle, the one the acute angle or the smaller acute angle in the blue right triangle, and that would be arccotangent of adjacent x over opposite, which is 30 feet. And that would be the answer to part A. Write an equation for d theta dx is the next one. So we have to get derivatives here. I'm going to write here the derivative of cotangent. It's negative 1 over the argument squared plus 1. In this case, our arguments are x over 50 and x over 30. But this is the derivative of arccotangent of x. I'm going to erase it because I need the space to write. d theta dx, I'm going to change colors. d theta dx is negative 1 over the argument x over 50 square plus 1, and then by the chain rule, derivative of 1 of x over 50, which is 1/50th, minus the derivative of the arccotangent, which is negative, and that becomes positive 1 over the argument x over 30, that's the argument of the arccotangent square, plus 1, times the derivative of the inside function or the argument, which is 1 over 30. Okay? We should really simplify this. Okay. Let's see. This would be definitely negative. This would be x squared and 50 squared, which one of the 50s cancels with this one. This would be 50 squared over 50 squared. Okay, so that would be negative. It would be x squared plus 50 squared divided by 50 squared, but times the 50, that cancels, and instead of, it's 1 over, so reciprocal, that's 50 over here. And this is plus, so it turns out to be 30 over x squared plus 30 squared. You can write 2,500 and you can write 900 here. Okay, and this is d theta dx. That's the answer to part B. The sign is easiest to read at the value of x where theta stops increasing and starts decreasing. This happens when d theta dx equals 0. Find this value of x. So we want d theta dx to equal 0. Okay? So we're going to solve this equation. I'm going to erase this other part. Okay. If this is 0, I can easily move this fraction to this side or add the same fraction so that we have a proportion. Okay, so that would be, and yeah, I'll leave it there. 50 over x squared plus 50 squared equals 30 over x squared plus 30 squared. Solving this proportion, I'm going to multiply 50 times this one and 30 times this one. I mean, product of the means equals the product of the extremes. Means and extremes. So that would be 50 times x squared plus 900. See, I'm changing it to 900. Equals 30 times x squared plus 2,500. Which becomes 50x squared plus 45,000. Yes. Equals 30x squared plus 75,000. Okay, like all the x's on one side, that would be 20x squared equals 30,000, which means x squared equals 30,000 divided by 20 is 1,500, and x, in this case we are only interested in the positive square root of 1,500, which is 30 something. Find this value of x. The exact value, 10 square root of 15, which we can write as a decimal. And that's it. Okay.